So now we're going to look at what happens if we throw in an extreme value. So we've got somebody coming through at 100 miles per hour. That's a lot larger than all of the other ones, but we're going to see how it changes what's going on here. So for this one, we already found the interquartile range was 10. So it's 10, we already found that. The median we found up here was the same thing as the standard, as the second quartile, that's 32.5. All of the other things, the mean and the standard deviation we can get. Is it already on here? Yeah. All right, so I ran my 1-bar stats. I've got my mean up at the top is 32.1. And then my standard deviation for this one, do I want to do S or sigma? S, yeah, so I'm going to write a 6.2. S, and that's because it's a sample of 14. They did a random sample of 14 cars, so since they're using a sample, it's going to be S and not sigma. Sigma would only be if they did every car that goes through that construction zone. Okay, so those are my values with the first 14 cars that they talked about. But now with the 15th car, this new car that's going 100 miles per hour, I'm just going to tack that onto my L1 at the bottom. So I come down here, bottom, and type in a 100 for my 15th car. Then I can go through again and run my 1-bar stats and get my values. All right. So now that I've thrown in that 15th car, my average becomes 36.7. And my standard deviation is still going to be S because it's still a sample, and that's 18.5. And now I need my median, that's down here. That's 33. And then for my interquartile range, they don't actually tell me what it is. So I have to actually do my formula. Interquartile range equals Q3 minus Q1. So Q3 is 39, Q1 is 28. So if I do 39 minus 28, I get 11. Okay. So, all right, when we did the mean and the median, we talked about what it means to be resistant. Resistant means that if you throw in an extreme value, either large or small compared to the rest of them, the median isn't really going to change all that much, but the mean will. So here, if you look at these two, the median only went up by like 1/2, but the mean went up by 4.5, 4.6, so it increased quite a bit. So we're going to have that same thing down here with our measures of dispersion. So standard deviation we already talked about was not resistant. This is pretty egregious that it goes from 6.2 all the way up to 18.5. You know, it almost triples in size. But if you look at your interquartile range, it starts at 10, but when you throw in this large number, it only goes up to 11, so it only goes up by 1. As opposed to like 12.3 like this one does here. So actually the interquartile range is going to be a resistant measure of dispersion. It's the only one that we have. So the interquartile range is resistant. Just like the median. Which makes sense, because when we're looking at the interquartile range, we're only looking at the middle 50% of data values. So if you throw in an extreme value, really large or really small, it's not going to mess with what's going on with the middle. You know, it's going to change the range, but it really won't affect our interquartile range at all. So the interquartile range is resistant just like the median. Technically the mode is resistant as well. But come down here, just a quick summary. Remember, deciding which one to use. The mean is the most popular, and if we have a symmetric distribution, you can go ahead and use it. But if our distribution is skewed one way or another, that's going to kind of mess with what the mean is doing, because the outliers are going to kind of pull the mean one way or another, and it's not going to accurately represent the entire data set. So if it's skewed, we have to use the median because it's resistant. Same thing with our measures of dispersion. Standard deviation is the most popular. As long as it's symmetric, you can go ahead and use that one. But if you have a data set that's skewed right or skewed left, standard deviation is going to be thrown off quite a bit by those extreme values. So you don't want to use the standard deviation. What you want to use instead is the interquartile range, because that one is resistant. So if it's skewed one way or another, you want to use the measures that are resistant. But if it's symmetric, you can go ahead and use the mean and the standard deviation, the ones that are more popular. That's fine. But just if it's skewed, it's best not to use those ones because they're not very accurate. So the last thing we're going to talk about is, nope, not the last thing, sorry. We're going to talk about outliers, and then we'll talk about percentiles, and then we'll move on to 3.5. Okay.